This is the first in a series of videos about my transition from regular programming to a paired style of development where my partner is Claude Code. I haven't written a single line of code in almost 3 months, but in that time we've shipped a production web application, tens of thousands of lines of Python, HTML, AI prompts, a public API, background job processing, multi-tenant architecture, security scanning, a full stack. 4 complete release cycles, built, tested, accepted, but I didn't write any of it. And I'm not going to write code in the future. It's quite a claim, and I never thought I'd make it. So let me tell you how I got here, because it wasn't the journey I expected, and I was a skeptic for longer than you might think. When ChatGPT launched in November 2022, like most people, I was impressed, but the shortcomings became apparent fairly quickly, and the risks of using it for serious work were obvious. Still, the genie was out of the lamp. Of course, I tried writing code with it. The output wasn't accurate or reliable enough to trust, so I put that experiment back on the shelf. 2 years on, DeepSeek released their R1 reasoning model. It was open source, and it was reported that it performed comparably to the closed source frontier models. We bought a second-hand 3090 GPU and ran a smaller DeepSeek model locally. With Python, I wrote code to download 200,000 web pages of test tool and services vendor website and PDF content. I used DeepSeek to identify terms that needed definition, generate market analyses on the testing tool space using a series of batch processes. We'd call them agents now. We got respectable summaries and some real value there. When I tried writing Python with DeepSeek, it did less well. Not ready was my conclusion. When GPT-5 arrived in August last year, I tried again. It could generate code, but I didn't have the confidence to push beyond trivial examples. I still wasn't convinced LLMs could do coding well enough. The pace continued. Every 2 or 3 months, a new model was released, measurably better than the last. My criticisms and many other people's had a shelf life, but I walked away 3 times, and I want you to know that because what follows isn't the story of someone who jumped on a bandwagon. It's the story of someone who kept testing the water and kept finding it too cold, until one day it wasn't. In January this year, I started using Claude as an alternative to ChatGPT, and something felt different. It wasn't as eager to please. When I asked it a question, it would offer alternatives and trade-offs rather than single, confident answer. It felt more like talking to a thoughtful colleague than a tool trying to impress me. I used it for general work for about a month, and then I thought, let me try writing code with it. So I started copying Python code into Claude's chat interface. I'd paste in a file, ask for changes, and it would do a reasonable job. It asked for modules it couldn't see, usually custom code from the application. So I'd paste in more files, more context, and Claude would offer an edited version. I'd paste it back into VS Code, check the changes, and my process worked quite well. It worked, but it was clunky. I did this for 2 or 3 days, and the code looked good enough to use. It seemed to work, and when it didn't work, fixes were easy. It wasn't perfect, but it was good enough. Good enough that I thought there had to be a better way, and of course I started to use Claude Code. The obvious next step was Claude Code, giving the AI direct access to my development repository. And this is where things suddenly look different. I introduced Claude to the Visual Studio Code and repo I'd been working on. I asked it questions about the code structure, the HTML styles, the JavaScript, and I watched how it researched and worked out an answer. It would scan content, follow module references, trace how controllers connected to templates. It gave a running commentary on what it was doing and why. It asked me to approve bash commands, shell scripts, SQL queries. These pauses are a bit of a pain, but they do let you see how Claude is thinking. These pauses and confirmations let me read the code it's using to do research and assimilation. I see the decisions it poses to itself, how it thinks through them and takes action. It reflects and looks for more informal and information. It reflects and looks for more information and better answers. If you were watching a developer working through an unfamiliar code base, it seemed to behave the same way a human would. Systematic, methodical, sensible, thoughtful. That made an immediate and positive impression on me. I started with simple changes and then whole actions and page templates, so it had to understand the CSS framework, the conventions, the patterns already established in the existing codebase. When it wasn't consistent enough with styling, I asked how we could set a standard it would follow. Claude suggested adding conventions to a memory file so it would remember them across sessions. We talked and continue to talk at length about what I can do, what we can do to help Claude become a reliable development partner. It felt like a partnership. Claude writes the code, but I suggest the requirements. We discuss, we refine, we settle on what we're going to build, and then Claude builds it. Faster, and I realised after about a week, better than I could. And then it occurred to me, I've been writing code since I was at school, all my adult life, but I don't need to write code anymore. Not want, need. The code Claude was writing was cleaner, more consistent and more thoroughly structured than what I could produce working on my own pace. Perhaps I'm not a great developer. We'll see. But after a week of watching the quality of what was coming out, the honest assessment was Claude writes better code than I do. So why would I write it? I had to take a break and think through the impact of that realisation. This is a skill I've relied on for decades, my ability to write code. And I was looking at evidence that the most useful thing I could do was stop doing it and focus on the activities Claude couldn't do as well. Deciding what to build, defining how it should work, testing whether it actually does what we intended. This was my epiphany. Not that AI can write code, everyone knows that, but that the most productive thing a developer can do in 2026 might be to stop writing code and start getting very, very good at specifying what code should do. Once I committed to this approach, I needed a serious test, not a toy project, a real production application, something with multi-tenant architecture, background processing, a public API, security controls, something I could put in front of real users. That application is Requirements QA, or RecQA, a requirements engineering platform that helps teams write better specifications and catch problems before development begins. I'll tell you more about what it does shortly, but first I want to tell you how it got built, because the how is the point. For almost 3 months, Claude and I have been building dozens of skills and commands that we use to better plan, design, write code, test and diagnose failures. This isn't ask the AI to write some code and hope for the best. It's a structured development process, and before any code is written, there are a phase in it skills to run, checking whether the requirement is buildable, whether we have a detailed plan down to which files change and in what sequence, whether the repo is clean, whether the database schema is appropriate or needs changing. During development, there are mid-build skills, registering backlog items for future work, running unit tests against every functional change, raising feedback when specifications are ambiguous. After development, there are phase closure skills, augment and run a growing regression test suite, UI testing using Playwright, API testing with curl and Python requests, PyTest for unit tests. A mandatory security scan of all 150 plus actions to prevent unauthenticated access or cross-tenant data leakage. SBOM generation for supply chain transparency. Every release goes through these initialization and closure processes. There are no exceptions, and there are more static analysis checks in the pipeline. Checks for programming style, complexity analysis, security vulnerabilities, user experience checks. These are all lined up to be implemented as skills plus procedures that Claude will go through before releasing a feature that it's just built. You might be surprised. Coding, the actual writing of code to deliver a release scope, takes between 10 and sometimes 30% of the elapsed time between ideation and ready for test. The rest is discussion. Discussions mainly cover the requirements, sometimes features, sometimes working stories, design choice, implementation plans, trade-offs. Claude is an equal partner in all of those discussions. I make all the final calls on requirements and plans, but these are genuinely joint activities. We've had design discussions that lasted hours. The implementation that followed might take a tenth of that time. Now, the critics of AI coding are thoughtful, serious critics that I respect, and often say that the hard part of software development was never the typing. It's the thinking, the decision making, the understanding of what needs to be built, and they're absolutely right. That's exactly my point too. AI hasn't eliminated the hard part. Coding isn't quite a solved problem, but it's getting there. The hard parts are now specification and testing. It's made the hard parts the entire job. Specification, design, verification, that's what I spend my time on now. The detailed code design and typing is handled pretty well by Claude. The term dark factory has been used to describe manufacturing plants full of robots working with the lights out. But it's also being used to describe AI agents building and testing code without human intervention. The AI companies tell us most, if not all, new code is AI written. A small but increasing number of companies are building commercial applications with no one writing code. Once you accept that AI can write code and write it well enough to ship, the bottleneck moves. It moves upstream to the specification. If a developer with an AI assistant can build a feature in hours rather than days, a vague requirement doesn't cause a slow build. You get a fast build of the wrong thing. Unless you ask them explicitly, AI agents don't ask clarifying questions about ambiguous requirements. They make plausible guesses and build confidently, but in the wrong direction. The faster your AI builder works, the more damage a bad specification does. This is the problem requirements QA solves. It systematically finds defects, gaps, and ambiguities in specifications before they reach development. Then it closes the loop by handling the approved spec to the builder and tracking the build cycle through to acceptance. The builder submits implementation plans. The analyst using Rekka reviews and approves them. Your build partner might be an in-house or outsourced team of developers. It could be a team that uses AI to perform all the coding. Feedback flows back during the build. At the end, there's an as-built record compared against what was originally scoped. This is the discipline infrastructure that makes AI-assisted development trustworthy. Not, I hope the AI gets it right, but a systematic process with human approval of every requirement and code artifact. Human decisions at the transitions and machine-readable specifications at the centre. It's not perfect. This whole AI-assisted process is a work in progress. I want to be honest about what doesn't work because we all have valid concerns. Pretending otherwise helps nobody. Claude forgets things. We've built skills and checklists to prevent steps being skipped, but sometimes Claude doesn't execute a skill it should. So we refine the process continuously, and it's getting more reliable with every release. But it's not bulletproof. Complex requirements are hard to deal with. Ask any programmer. Giving Claude a 20-page requirement and asking it to build a major feature in one go is not a good idea. It's not a great idea to give it to a human programmer either. Sometimes what looks simple requires deep design thinking. Claude can usually break complex work into modules and functions, but sometimes it creates plans that are too ambitious. I'm actively working on better ways to assess requirements complexity and to split requirements and therefore design work appropriately. Diagnosis isn't always right first time. Claude has an impressive ability to trace problems when debugging. It can scan code, follow data flows, read crash traces, identify errors in deeply nested HTML. But sometimes it finds a solution that fixes a symptom rather than the cause. Or it misidentifies the root cause entirely. These events aren't common, but they do happen. It's almost human in its fallibility. None of this is a reason to stop the experiment. It's a reason to build better processes. And that's what we're trying to do, release by release. There are serious, thoughtful people who argue that AI-generated code is untested, unreliable, and irresponsible. They're right about the risks. They're right that most people use AI coding tools carelessly. They're right that the hard part of software development is thinking, not typing. But I think they're describing the average experience of AI coding, the folk who bolt Copilot onto an unchanged workflow and wonder why it doesn't transform anything. The interesting story isn't in the average, it's in what happens when you rebuild your process around specification-driven, AI-built development. When coding becomes 10% of the work and specification becomes 90%. When you build the discipline infrastructure, the skills, the checks, the verification that makes it more trustworthy. I now think more trustworthy than people under pressure trying to manage complexity that no one completely understands. That's what we're trying to do. Not perfectly, not without problems, but well enough to ship a production application that has commercial value and that was built without writing a single line of code. This is the experiment we're running. Over the next few videos, I'm going to explore this territory in more depth. The process, AI requirements generation and analysis, skills that keep AI honest and guardrailed, how AI writes code but keeps humans in the loop, and so on. And of course, when ready to go public, the requirements QA application itself. I'd genuinely love to hear your experience and opinions. Is this experiment flawed? If this resonates, please subscribe to the channel and hit the notification bell. The next video in this series is coming soon. Thank you for watching.